Good morning, my name is Sai Teja from ACB section. Today my topic is antenna characteristics. History of antenna. The first antennas were built in 1888 by German physicist Heinrich Hertz in his pioneering experiment to prove the existence of electromagnetic wave predicted by the theory of James Clerk Maxwell. Heads placed dipole antennas at the focal point of parabolic reflector for the both transmitting and receiving. He published his work in Annalen der Physics and Chemie of volume 36 in 1889. Introduction. An antenna is an electrical device which converts electric current into radio waves and vice versa. It is usually used with a radio transmitter or radio receiver. In transmission, a radio transmitter applies an oscillating radio frequency electric current to the antenna's terminals, and the antenna radiates the energy from the current as electromagnetic waves, radio waves. Transmitting antenna. Any structure designed to the efficient radiate electromagnetic radiation in a preferred direction is called a transmitting antenna. In reception, an antenna interferes some of the power of an electromagnetic wave in order to produce a tiny voltage at its terminal that is applied to a receiver to be amplified. An antenna can be used for both transmitting and receiving. Receiving antenna. Any structure designed to efficiently receive electromagnetic radiation is called a receiving antenna. Where the antennas are used. Antennas are used in a system such as radio and television broadcasting, point to point radio communication, wireless LAN, radar, and space exploration. Antennas are most utilized in an air or outer space, but can also be operated underwater or even through soil and rock at certain frequencies for short distances. Radiation mechanism. Ideally, all incident energy must be reflected back when open circuit, but practically a small portion of electromagnetic energy escapes from the system that it is jet radiated. This occurs because the line of force does not undergo complete phase reversal and some of them escapes. The amount of escaped energy is very small due to mismatched between transmission line and surrounding space. Also because of two wires are too close to each other, radiation from one tip will cancel radiation from another tip as they are opposite polarities and the distance between them is too small as compared to wavelength. To increase amount of radiated power, open circuit must be enlarged by spreading the two wires. Due to this arrangement, coupling between transmission lines and free space is improved. Also, amount of cancellation has reduced. The radiation efficiency will increase further if two conductors of transmission lines are bent so as to bring them in small line as shown in figure. The radiation pattern is look like as shown in figure with a main loop and which is at the another side of opposite side loop, and the side and small sided loops are present. This is the radiation pattern of antenna. The radiation pattern of an antenna is a plot of the relative field strength of the radio wave emitted by the antenna at different angles. It is typically represented by a three-dimensional graph or polar plots of horizontal and vertical cross section. It is a plot of a field strength in V versus sorry the angle in degrees. The pattern of an ideal isotropic antenna, which can radiate equally in all directions, would like to look like two spheres. Many non-directional antennas, such as dipoles, emits equal power in all horizontal directions, with the power dropping off at higher and lower angles. This is called an omnidirectional pattern. On the main loop maximum direction, and this is the main loop, and it has the half power point of left, and this is the half power point right, and the half power point beam and beam width between two knobs and minor loops. Folded dipole. Folded antenna is a single antenna, but it consists of two elements. First element is a feed directly, while second one is coupled inductively at its ends. Radiation pattern of folded dipole is the same as that of dipole antenna, figure of 8. Advantages: input impedance of folded dipole is 4 times higher than that of straight dipole. Typically, the input impedance of half-wave folded dipole antenna is 288 ohms. Bandwidth of folded antenna is higher than that of straight dipole. Hertz antenna. The Hertz dipole is a theoretical short dipole significantly smaller than the wavelength, with the uniform current along its length. A true Hertz dipole cannot physically exist, since the assumed current distribution implies the infinite charge density at its ends, and significant radiation requires a very large current over its very short length. And this is the Hertz antenna. Loop antenna. A loop antenna is a radio antenna consisting of a loop of wire which is ends connected to a balanced transmission line. It is a singleton coil carrying RF current through it. The dimensions of coil are smaller than the wavelength, hence current flowing through the coil has same phase. Small loop has a very poor efficiency and are main used as receiving antennas at low frequency. Except for car radios, almost every AM broadcast receiver sold has a such as antenna built inside it or directionally attached to it. A technically small loop, has also known as magnetic loop, should have a circumference of 1/10 of wavelength or less. This is necessary to ensure a contact current distribution around the loop. As the frequency or the size are increased, a standing wave starts to develop its current and the antenna starts to have some of the characteristics of a folded dipole antenna or a self-resistant loop. A self-resistance loop antenna are larger than they are typically used at higher frequency, especially VHF and UHF. where their sizes are manageable. They can be used as a form of folded dipole and have somewhat similar characteristics. The radiation efficiency is also high and similar to that of dipole. The radiation pattern of a loop antenna is a dot knot pattern. Can be circular or square loop. No radiation is received normally to the plane of loop and null is obtained in this direction. Application used for direction finding applications. Antenna arrays. Antenna arrays is a group of antenna or antenna element arranged to provide desired directional characteristics. Generally, any combination of elements can form an array. However, equal elements of regular geometry are usually used. Yagi-Uda antenna. It is a directional antenna consists of a driven element, typically a dipole or folded dipole, and additional parasitic elements, usually so-called reflector and one or more directors. All the elements are arranged collinearly and close together. The reflector element is a slight longer, typically 5% longer than the driven dipole, where the so-called directors are a little bit shorter. The design achieves a very substantial increase in the antenna's directionality and gain compared to a small dipole. And this is the Yagi-Uda antenna. Typically, a spacing between elements vary from about 1 by 10 to 1 by 4th of wavelength, depends on the specific design. The elements are used parallelly in one plane. The radiation pattern is modified, figure of 8. By adjusting distance between adjacent director, it is possible to reduce back loop, improved from to back ratio. Radiation pattern consists of main loop, back loops, side loops. Antenna applications. They are used in systems such as radio broadcasting, broadcast television, two-way radio, communication receiver, radar, cell phones. Satellite communications. Antenna considerations. The space available for an antenna, the proximity to neighbors, the operating frequencies, the output power, and the money. The antenna array is a group of antenna or antenna element arranged to provide desired directional characteristics. Generally, any combination of elements can form an array. However, equal elements of regular geometry are usually used. And this is the Yagi-Uda antenna with the length of 0.5 of reflector and the directors are 0.43 lambda and the distance between them is 0.25 lambda and 0.13 lambda. It depends upon the size of an antenna. Typical space between them are varies from about 1 by 10 to 1 by 4th of its wavelength, depending on the specific design. The elements are usually parallel in one plane.